This is Pre-Calculus Section 1.8 Day 2 Notes. We're going to start today by talking about symmetry testing. So the first kind of symmetry that we can have for a graph is symmetry with respect to the x-axis. And the way that you test for this type of symmetry is in the equation you would replace y with negative y. And there is symmetry with the x-axis if the equation remains the same as the original equation. We will do some examples of this later in the notes. So a graph that has symmetry with the x-axis, you can see this curve right here that has the point 1, 3. Well, if it's symmetric with the x-axis, then you would also have the point 1, negative 3 on the curve as well. And it would look like that. The second kind of symmetry we can have is symmetry with respect to the y-axis. And our test for that is in the equation we replace x with negative x. And there's symmetry with the y-axis if the equation remains the same as the original equation. So symmetry with the y-axis almost looks like the y-axis acts as a mirror for the graph. So if the point negative 2, 4 were on the graph, then the point positive 2, 4 would also be on the graph that has symmetry with respect to the y-axis. The third type of graph here is symmetry with respect to the origin. So with this one, if you're going to test for symmetry with respect to the origin, you are going to replace x with negative x, and you are going to replace y with negative y. You're going to do both of these at the same time. And there is symmetry with the origin if the equation remains the same as the original equation. Graphically speaking, a graph that has symmetry with respect to the origin almost looks like it's been rotated through the quadrants. So if the point positive 3, 4 were on there, then the point negative 3, negative 4 would be on there as well. So now let's put these tests here into action. It says test this equation for symmetry. Make sure you show your work. So we want to test the same equation for symmetry with the x-axis, with the y-axis, and with the origin. So when we're testing for symmetry with the x-axis, remember this is where we are going to replace y with negative y. So right in the equation, wherever we see y, we put negative y. So we're going to have x equals negative y to the fourth power minus negative y squared. When we simplify this, though, a negative number raised to the fourth power becomes positive. So this remains y to the fourth, and this negative y squared remains y squared. So we end up with the same equation as the original equation. Okay, so that tells us yes. Next, we're going to test for symmetry with respect to the y-axis, which means that we are going to replace x with negative x in the equation. So it's going to look like this. Negative x equals y to the fourth minus y squared. Okay. And right now it doesn't look the same, so if we try to make our x term positive, if we divide everything by a negative 1, then we end up with negative y to the fourth and positive y squared, right? So this is a no. It doesn't come out the same. And then finally, if we're going to test symmetry to the origin, we are going to replace x with negative x and replace y with negative y. We're going to do this all at once. So we're going to have negative x equals negative y to the fourth minus negative y squared, and we're going to simplify, and we get negative x equals y to the fourth minus y squared, which is the same thing that we ended up with before. And again, if we wanted to divide by negative 1, then we'd end up with x equals negative y to the fourth plus positive y squared. So once again, this is a no, right? So yes, we have the same equation and it is symmetric, and then no and no. The next example asks us to find the x-intercept or intercepts and y-intercept of y equals x squared minus 2. Hopefully this should be reviewed. To find an x-intercept, you plug in y equals 0. And to find a y-intercept, you plug in x equals 0. So our x-intercept, when we plug in 0 for y, we get 0 equals x squared minus 2. So then we have to solve by getting x squared alone. And then in order to solve for x, we have to square root both sides. And whenever we square root, we get 2 answers. So our two x-intercepts are positive and negative square root of 2. If we wanted to write those as ordered pairs, it would be positive square root of 2, 0, and negative square root of 2, 0. The y-intercept, we're going to plug in x equals 0. So we're going to get y equals 0 squared minus 2, which just tells us y equals negative 2. So that is the ordered pair 0, negative 2. So we just found our x-intercept and our y-intercept. The next examples ask us to complete the graph using the given properties, symmetric with respect to the y-axis. So remember, this just looks like there's a mirror that's lying right on top of the y-axis, and we need to reflect this graph over the y-axis. So it's going to look something like that. Symmetric with respect to the x-axis just means that our mirror is the x-axis and we have to flip our graph over the x-axis. Something like that. And then symmetric with respect to the origin basically means that this graph gets rotated around. Either clockwise or counterclockwise, doesn't matter, but you're going to be rotating it 2 quadrants. Now we're going to switch gears a little bit and we're going to start talking about circles. This is all kind of part of coordinate geometry. The standard form of the equation of a circle with a center hk and a radius r is x minus h squared plus y minus k squared equals r squared. Our first example in this section asks us to find an equation of a circle that satisfies the information having a center at 1, negative 2, and a radius of 3. So remember, our center is our hk and our radius is our r. So our equation is just going to be x minus 1 squared plus y minus negative 2 squared equals 3 squared. But we don't want to leave that like that. Obviously, we want to do some chop here whenever we have minus and negative, and then we can clean up our 3 squared as well. So our final answer will be x minus 1 squared plus y plus 2 squared equals 9. And if we wanted to graph this circle, our coordinate plane, our x-axis and y-axis are right there. So our center would be at the point 1, negative 2. And then if our radius is 3, we would just count out 3 units up, down, left, and right from the center of our circle. And then you just kind of do the best that you can to connect your points with a circle. And that would be the graph. Our last example asks us to find the center and the radius of the circle given by the equation. But this equation doesn't look anything like the standard form equation of a circle, okay? So our first job here is going to be to change it into the standard form of a circle. We're going to do this process by completing the square. So first what we're going to do is we are going to group our terms together. You're going to get your x squared and your x and your y squared and your y. We're going to group those together, and then we are going to complete the square for both terms. And this is something that we spent a lot of time working on in Algebra 2. So hopefully it will ring a bell when we do it. So the first thing I'm going to do here is I'm going to rearrange my terms. I'm going to put my x squared and my negative 6x right next to each other. I'm going to leave a little space. Then I'm going to put my y squared and my positive 10y right next to each other. I'm going to leave a little space. And then my constant term of 8, I'm going to move over to the other side where the 0 is, so when I subtract that over, it becomes negative 8. Now, the space that I left here is for the boxes that I'm going to be adding, because when you complete the square, you add a box. So I'm going to be adding a box to complete the square for the x's, and whatever I do to the left side of the equation, I also have to do to the right side. Remember, to figure out what goes in the box, you take your b value, you divide it by 2, and you square it, right? Well, my b value is negative 6. Negative 6 divided by 2 is negative 3, and then negative 3 squared gives me 9. So I'm going to add a 9 to the left side, and I'm going to add a 9 to the right side. Now I have to repeat the same process again with my y values. So I'm going to add a box for my y values on the left side, and I'm going to add that same box on the right side. And again, to fill in the box, I have to take my b value, divide it by 2, and square it, which in this case is 10 divided by 2 and squared. So that's going to be 10 divided by 2 is 5. 5 squared is 25. So 25 is going to go in the box. Okay, now that I've done that work, I can go ahead and I can do the factoring. So these three terms are going to factor into the same binomial times itself, and it's going to be x minus 3 quantity squared. These three terms are going to factor into the same binomial times itself, y plus 5 squared. And then over here, I'm just going to add my constant terms together. Negative 8 plus 9 is 1. 1 plus 25 is 26. So now I have transformed my equation so that it's in the right form, and now I can see the center of my circle. It's HK, so I know this is going to be my H value, this is going to be my K value, and this is my R squared value. So the center of my circle is going to be positive 3, negative 5. Remember, we have to switch the signs when we pull it out of the equation because it's always x minus your h value and y minus your k value. And if r squared is 26, then that means that the radius is the square root of 26, which, if you grab your calculator, is approximately 5.1.